So let's go through FPM module 5, which clearly states about pumps and valves and their usage and all. So there are mainly two types of pumps. One is a posterior displacement one and another is a rotodynamic pumps. Posterior displacement pump, as we usually know, it is a major class of pumps and which has a chamber where a liquid is trapped in a chamber which is filled with inlet and is emptied at a higher pressure. There are mainly two subclasses of posterior displacement pump. One is a reciprocating pump and other is a rotary pump. So for a reciprocating pump, we have an examples of piston pump, plunger pump and diaphragm pump are example. These are chosen in order of its pressure changes, and for a low pressure of 50 atm we choose piston pump, and for pressure up to 1500 we choose a plunger pump, and up to 1000 atm and more we can choose a diaphragm pumps. So the mechanical efficiency for reciprocating pumps varies from 40 to 50% for small pumps and 70 to 90% for a larger ones. Mostly reciprocating pumps are used for a low for a high pressure treatments only. So speaking of an example of posterior displacement pump, the most important one is a piston pump. So let's speaking about the piston pump. In a piston pump, the liquid is drawn through an inlet check valve into a cylinder and there are two cylinders. So when a liquid is entered into one cylinder and the other cylinder would be empty, and it is just pushed by a piston to the other cylinder and is thrown out. So the liquid admitted alternately on each side of the piston, so that one part of the cylinder is being filled and one side is filled and other is emptied. Often there are two or more cylinders in parallel with a common suction and discharge headers. So the configuration of the piston is adjusted to minimize the fluctuation of the discharge rate. So these pistons may be a motor driven through a reducing gears by using gears, or can be a steam tapped piston can be used, and the maximum discharge pressure is about 50 atm for a piston pumps. So this is a general example for a posterior displacement pump. So next we are going through the rotary pump. So rotary pumps, we can say we have a rotary gears in that. So gear, we have two examples. One is a gear pumps. We have two examples. One is a spur gear pump and internal gear pumps. So in a spur gear pump, the intermachine gears rotate with a close clearance inside a casing. And the liquid entering the suction line at the bottom of its casing is caught. In this, there are spaces between the teeth of the gears, and this liquid is caught between them and the casing and is carried around to the top and is released through there. So there is no short circuiting between the liquids and back, and it won't return to the suction area because of the close mesh of the gears in the center. The internal gear pump is spur gear or a pinion meshes with a ring gear with an internal tail. Both gears are inside the casing. The ring gear is coaxial with the inside of the casing, but the pinion, which is an externally driven, is mounted eccentrically with respect to the center of the casing. A stationary metal crescent fills the space between the two gears. Liquid is carried inlet to discharge by both gears. So the space between the gear teeth and the crescent, keeping the space. And the most important factor in an internal gear pump is its crescent, which is a stationary metal crescent, which is not present in a spur gear pump. So next topic is a valve. To show, basically valves are used to slow down or stop the flow of liquid. So valves can be of different types. Some valves rest in an on or off service, directly on and off. Some are fully open or fully closed type, and others are designed to throttle, that is changes in the pressure or reduce the pressure or flow rate. There are some valves which are only unidirectional, which only permits unidirectional flow, that is example. So the foot valves that we use in our wells and all, that is a unidirectional valve, example of a unidirectional valve. So speaking of example of valves, there are mainly many valves, many types. That one is a globe valve, one is the gate valve, globe valve. We have plug check valves, ball valves, and the check valves. Check valves are used or are unidirectional valves, and plug valves and ball valves of another type. And the next we are going to the gate valve. So in a gate valve, the diameter of the opening through which the fluid passes is nearly the same. and that of the pipe, and the direction of flow does not changes in a gate valve. As a result, a wide open gate valves introduced only a small pressure drop. The disc is tapered and fits into a tapered seat when the valve is opened. The disc rises to a bonnet, completely out of the path of the fluid. The gate valves are not recommended for controlling flow, and it is usually felt open or felt closed. So these are a type of valves which are left fully open or fully closed. You can note the example gate valve. The next important valve is a globe valve. Globe valves are widely used for controlling the flow in a various industrial applications. You can see globe valves in many places. So the opening increases almost linearly with the stem position, and wear is evenly distributed around the disc. The fluid passes through a restricted opening and changes directly several times, and can be seen by visualization through flow through a valves illustrated in figure 8.3b of McCabe-Smith. And as a result of pressure drop, this kind of valve is large. So globe valve can measure up to high pressures, and it can tolerate high pressures, that is peaks. So the next valve is a ball valve. It is one of an important valve. In a ball valve, the sealing element is a spherical, and instead of stem, here we have a spherical sealing element, and the problem in the alignment of the element are less than that of a plug cock. So it is another type. Plug cock is another type. So in both plug cock and a ball valve, the area of contact between the moving element and the seal is large, and both can therefore be used as a throttling devices. So saying that ball valve and plug cock valve are throttling devices. Ball valve find occasional application in the flow control and in the pressure control in various industries. So we have been to the introduction part. So I am only speaking about the introduction part of the module 5. So module 5 is a little bit interesting one with the theory portion. So the important theory portions are centrifugal pump theory and characteristic curves. We must also note the pump diagrams and the valve diagrams. We must study to draw the pump diagrams and valve diagrams neatly, and they may be asked for exams. We must also note about the theory of reciprocating pump as well as with the centrifugal pump. That as I spoken in the previous slides about piston pumps, etc. So valve types I've spoken of globe valves, gate valves, ball valves, plug cock valves, and check valves. We must also note them along with their diagrams, and also go through the textbook of McCabe-Smith, chapter 8, which speaks about pumps and valves, which is an important for a module 5, and its basics must be learned. So we can go through further classes. It is important to know about pumps and valves for our industrial applications and studies. Thank you.